Okay, so this video is on finding inverse functions. We're going to talk a little bit about what an inverse function is, and then we'll talk about some simple steps on how you can take a function and find its inverse, and then also a test for um, um, proving if you do have inverses. So, first of all, an inverse function, we've talked about inverse operations. Okay, so for example, when you take we know, for example, that if we have an equation that contains addition, the inverse operation that we would use to undo that addition would be subtraction. Okay, and vice versa. Have subtraction, we would use addition. Same thing is true if we have a equation involving multiplication, then we would use division to undo it, to get rid of it. And again, vice versa if we were given the division problem. So inverse operations have a way of allowing us to simplify to a simpler expression, okay, or an simpler equation. Well, in a similar manner, inverse functions are functions that, when you look at them in conjunction, are basically inverses of each other. Okay, they're almost like opposites of each other. If you look at their graphs, okay, if this is our xy axes, there is an imaginary line called the identity line that passes through where y equals x. Two functions that are inverses of each other will reflect over that line. Okay, so if you would have a parabola, for example, that we know will do something like this, okay, then the inverse of that would do something like this, okay, where each one of these parts of the graph would flip over across this diagonal line of symmetry, okay? So that's what's true. Now, we're not going to deal with graphs, okay? So that's going to be an important part of this here is that we're not going to deal with the graphs. We want to look at simply how do we take one and get the other. And there's a couple different formats we're going to look at here, okay? So if we have a function, and the first two problems are going to be just like this. If you have a function that contains the following points, let's say f of x equals the set of points, let's go 0, 2, 2, 4, 4, 6, and 6, 8. Okay? Now, the inverse to that particular function then, because of the relationship, can be found by taking and switching the x and y coordinates of each one of those ordered pairs. So 0, 2 becomes 2, 0. And then 2, 4 is 4, 2. 4, 6 is 6, 4. 6, 8 is 8, 6. Okay, now notice the change in notation here. I don't expect you to use this, but recognize that since I have, if this is the original, f to the -1 power is the symbol that we use to represent the inverse function. So here was the original. I switched all the x and y components, and I got the inverse. Okay, so that's the first thing they're going to do. Okay, is they're going to ask you to do that, and I'll do another one of those with you. Okay, another thing they're going to ask you to do is take a function and change it to its inverse, not just points, but the actual equation. That's a 5-step process. I'll outline the process with some examples here in just a minute. And then the last thing they're going to talk about is how do you test to see if two functions are inverse of each other? So if I know I have function f and I have function g. In the previous unit, we talked about how to do compositions. Okay, compositions are a great way of testing for inverses. So what you do is, if I take g and plug it into f, and I take f and plug it into g, it requires 2 tests. Both of these have to be performed. Okay, when you're done simplifying, both of them will reduce down to the variable x. And that's it. Everything else will cancel out completely. If both compositions reduce or simplify to x, then you can say, yes, the two functions are similar to each other, or excuse me, are inverses of each other. Okay, so that's what they're going to ask you to do. The worksheet has a lot of problems. After I looked at it, I kind of went, what am I doing? There's no reason you guys need to do this much. So here are the problems I'm asking you to do on this worksheet that's entitled 7.4 Inverse Functions. Okay, so circle 1 and 2, circle 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, and then on the bottom, circle 20, 21, and 24. Okay, so that should be 15 problems. Okay, and that's all to do. Do not do, you should have this backside. Okay, do not do any of the problems on that backside. Okay, it's just more than we need to mess with at this point. Okay, so let's talk about how we're going to do these. Okay, questions 1 and 2. Okay, find the inverse. Well, when you're given a set of points like this, to find the inverse, we just said switch the x and y coordinates. So for number 2, you should have order pairs 7, -5, -8, -6, -2, +1, +3, +10. That's it. Okay. Now, for 4 through 14, okay, find an equation for an inverse given a function. So I don't have a whole lot of room here, so I ask you that you do these on a separate piece of paper. If you staple it on, that would be best then, and just turn it in when the worksheet. On number 6, okay, it's given in y equals form, so that's perfect. That's what I want here. So here's what I want to do. Okay, I know that y equals -8x plus 16. First step is to interchange the x and y. So x equals -8y plus 16. Okay. Just like we switched them above and on number 2, we're going to switch them here. Now solve this equation for y. So I'm going to solve this. I'm going to subtract the 16 over. I get x minus 16 equals -8y. And then I'm going to divide both sides by -8. So if I switch the sides over, then y equals, I'm going to move that negative. I don't want negatives down the bottom, so I'm going to move a negative out in front, just like this, negative. And then I'm going to put x minus 16 here, and then 8 here, and there's your answer. Okay, so given this equations, okay, this is my inverse. Now, if you kind of look at it, it contains inverse operations. The original had plus 16 The new one has a minus 16. Okay, the original had times negative 8. The inverse has divide by negative 8. Okay, so that's going to be fairly common with these kinds of problems. But do the steps, okay? Otherwise, you're going to end up with some little arithmetic errors that you probably wouldn't normally make. Do the steps, spell it out, show the work, okay, and then give me that final answer. Okay, 7, 8, and 9, or 7, 8, and 10. The only difference there is the fractions. So I wanted you to do one like that. Number 10. If I know that y equals 1/2 x plus 8, okay, then again, start out by switching the x and the y, and again, solve. So I'm going to subtract the 8 over. And to get rid of the 1/2, I'm going to multiply both sides by 2. And I don't want to forget to distribute that. Okay, so this would be 2x minus 16 equals y. Or y equals 2x minus 16. But answers that are very similar, okay, to ones you just did on those first 3 problems. Okay, the answers look very similar to the problems you started out with. Okay, the only difference on these last ones, and I gave you 4 of these, okay, but each one of these is a quadratic, okay, and so you're going to end up with some things on your some things with your answers that I wanted you to be careful about. Let's do number 14. If I know that y equals x minus 6 quantity squared, again, switch. So x equals the quantity y minus 6 quantity squared. Now think about what you have to do to solve that. To get that y by itself, my first step is going to be to undo that square, that exponent. So to undo a square, you need to square root both sides. So the square and the square root on the side cancel. You're left on the right side, and you're just left with y minus 6. On the left side, we've got square root of x. To finish the problem, I'm going to add the 6 over. So you could bring the 6 out in front. You can put it after. Just don't put it underneath the radical. It is not, on these problems here, it is not under the radical. It will be on some of the other problems here, but not on this one, on this type. So 6 plus square root of x equals y. Okay, and there's your inverse for that problem. Okay, lastly, on the bottom of the page where you're testing to see if you have inverses, again, remember we're forming composites. So let's do number 24. And remember, cross this out down here. Don't do the backside. Okay. So number 24. If I go f of g of x first. Okay. This thing says take the function g and plug it into f. So f is 1/2 x minus 7. Okay. G is inside for x, so 2x plus 14. Okay, so I literally took g of x, the function g of x, plugged it into this x, this is f of x, to get this. Now my next step is to distribute. So 1/2 of 2x is just x. 1/2 of 14 is 7, minus 7. The plus 7 and the minus 7 cancel, so I'm left with x. Okay. We're running out of room. So you get that. Now, again, now you also have to do the other side. So g of f of x. This time I'm going to start with g, 2x plus 14. Instead of the x, I'm going to plug in f, 1/2 x minus 7. Okay, and distribute both through, the 2 through. You get x minus 14, and then bring down the plus 14. And again, the 14s cancel, you're left with x. So based on this is x and this is x, we can say yes, the two functions are inverses of each other. Okay, so you're going to have similar work for numbers 20 and 21, just showing me how you take the function, start with that very outside one, and then the one that's inside gets substituted in, and then do the simplification. Okay, so that's what I want you to be able to do with inverse functions. Test questions are similar, and hopefully I haven't got the too drastic, but those are the problems for this unit, 15 there. Okay. Email me if you have additional questions.